Hello, everyone. Sorry. Okay, so this time, working on something I spoke about in a previous stream a while back. I think it was with Gold Bounty. Idea about a 2D platformer that has shifting gravity and interacts with player, maybe objects. Um, yeah, I thought, give it a shot this time. So, suppose we should get started. Just get a bit of coffee. Excellent. Alright, yo. Gravity shift objective. 2D platformer. Where... Whoa. 2D platformer where gravity shifts and affect. So hang on a second, there's a bit of English here. I think it's affect. As they jump around a level. Let's see. Gravity controls can be triggered by the player. Good starting point, I suppose. So, give you a little rundown of the idea behind it in a bit, but we'll sort out this to-do list first. To-do list 1. Well, let's start off with create a level for testing. Create level 00 as per usual. Whoa. Where's my bullet points? Create a basic tile map. Well, create a basic tile map for testing. Go define custom controls. So we'll be needing it this time. Not just because it isn't a simple top-down game that I've been making the last couple of streams. Well, you could use what's built into the engine, but we need to think it'll be best if we create our own custom one because we're going to be doing some other stuff that it'll just be better if we had extra controls. Let's see. One thing I've been forgetting to do is set up the project resolution. I think I forgot to do it last time. Like, it's not so much a bad thing, it's just testing stuff out, but with this, I don't know. Keep it working, well, consistent across things. Alright. To-do list 2. Player platform behavior. Create player. Create player. Add in platform controls. That'll work. That'll be for later on. Yeah, that's right. People aren't psychic. You can go through what you're saying. We're going to use move and slide. Start off with. There are different ways of using a kinematic. Moving a kinematic body around. Move and slide. That's what we've been using for top-down games. There's an extra one called move and slide with snap. That requires a little bit extra, so we'll just keep it using this one because it's simple for the moment. So it's going to get complex later on. Well, more complex, I suppose. There's two. Oh, wait, 1, 2, 3, yep. Manipulate gravity. Tie forces to a single vector. That will make sense later on when we actually get to manipulating it. Rotate, shift, change, whichever. Deal with player control. And shift gravity. And that'll be good to start off with, depending on how this behaves. Like, oh, full disclosure, as per usual, just me trying to, you know, level with you guys as always. This is an idea that I had a while back, but something always messes up, and, well, as it goes with learning stuff relating to games, you come across new tricks and tweaks and little spiffy things that could work for older things. Like what didn't work in the past could work now. Yeah. Well, we'll leave that there for now. So create the level, platform behavior. I know how to do these, and I'll just run through it with you guys. That's pretty straightforward. Manipulating gravity. Got a few ideas for that. Well, suppose you just get started. I mean, no point sitting around like this. Alright, so get our handy dandy A-Sprite open. More coffee. Rightio, so basic idea for it is we have not that. Pressure a wee bit. I'll leave it for. Rightio, so we have our player object. We have our ground. Like that. And the scooch you down a wee bit. And give you a slightly different color. That'll do. Rightio, so with a 2D platformer or side scroller, whatever you call them, the player needs to do a few things. It needs to move left and right, needs to jump. That's pretty straightforward. You should be able to knock that out. Comes to slopes, well, this looks a little bit too steep, but player will need to move like that eventually. And down as well. Before I got into reading the docs, like as I'm developing stuff, this is all gone back a few years when I first started learning Godot, didn't know about things like move and slide with snap, which we'll get to later on. So it was a big white whale of working out, how can I get a player to move down slopes like a staircase instead of going woo off the edge. I'll show you that part in a bit because we're putting in a basic one. You'll see what I mean. So that is the basic idea for platform behavior. To make sure everything works, we need to have a force of gravity. In this case, it'll be going down. So if you want a player to jump, you just say, okay, set its, well in this case, y-axis. Oh, let's just give it a bit of jump strength. So this jumps up while being acted on by gravity in the physics, then pulls it back down. When it's on the floor, then gravity isn't working. So it's jump, jump, jump. Gravity is always working on it. You go to edges, so that it flies off the edge with the basic move and slide. It'll be like moving to the edge. Oh, there's nothing down below. It's not on the floor. Apply gravity. So you may think, oh, it goes like this. In fact, it'd be more like whoop, down. For now, we'll just keep basic move and slide functionality. But the important part here is this gravity fella here. If we think of gravity as a vector, this will be 0, 1, facing down as a direction. What we'll be doing is we'll be making something like, let's go here. Over time it rotates on shift. Let's go from down, say we're going to shift gravity to the left side of the screen. Set it to left and it will rotate. So platforming behavior, this is part 1. Part 2, shifting gravity as a variable between different points. Oh wait, so the second one would be, that'll be -1 at x0. And we want to make it for all directions, so it'll be up, right, etc, etc. Well, instead of talking about all this stuff, let's just get there and start building some things. Because this gravity shifting part I've had problems with in the past, but well, I think it would be best if I show you. We'll just make it, I suppose. Let's see, we are jumping to Godot. I've already got a thing. I do. Radio. Level 00, we're going to save you in a new folder, call it Scenes. Save. Come in here, we're going to add in a tile map. Before I forget, project settings, we're going to go to window. Wait, window, where are we? There. 640 by 360. Keep going down. 1280 by 720. Yep, we're going to go to Modi mode. 2D, we're going to, not ignore, keep. So, the grid, that'll work. So is a 64 by 64 spaced out. That's fine. Cell size, 32 by 32. Shave. Let's pop back into A-Sprite. New project, we're going to make you. Keep it basic for now. We can always make it bigger next time. 64 by 64. View, grid settings. That's 32 by 32. Yep, that's good enough. We'll keep this color scheme. That'll be fine. So we need a floor color. Let's go. Let's make it stand out a wee bit. Let's go here. We're going to go here. There. Whoops, that is not right. There. We're going to go. Two, three, four. I'm gonna move you. Oh no. There we go. There. Put you. Two, three, four. 1, 2, 3, 4. Yep, and whoop, L. Put you a little one there. 2, 3. Yeah, that all works. Okay, put you there. Wait, there, and there. So we can see. So we can make it stand out. Just leave it like that. Yeah, that'll do. Whatever. So pop up and save you in. Here we're going to go sprites. Sprites. We're going to save you as tile map placeholder. I just thought of a better way of doing this, but save that for later on. Just export. We are going to go to sprites. Going to make sure we re-import this as pixel. Yep. Default for texture. Okay. Tile set, new tile set. Jump in here. We're going to add in the sprites. Tile map placeholder. We're going to go new single tile. Put up the region that's already locked there. We're going to call this floor flat. Yep. That's fine. That's fine. All of that's fine. It'll put in collision shape as a square. That'll be there. Yep, everything should. Wait, collision. Oh, it's on 1 and 1. That's fine for now. Okay. There. Going to rotate you like this. Let's go here, copy, paste. Do. Whoops. That'll do. Okay, so we're going to go tile set, come into here, move across. We're going to go region, new single tile. Going to put you there. Collision. Don't think it's that necessary, but we'll chuck it in to be safe. Floor, core. No. Yeah, okay. So I come back to here. You and there. You and there. You and there. You and there. Yep. Going to select level 0 as our thing. There we go. Ooh, maybe a background, I suppose. Oh, let's see. Sorry that I'm doing this more than getting to the point. Just warming up a wee bit. Save. I don't know, sometimes it's nice to make things look a bit more interesting. Well, not so much interesting, just having something visual there. We'll call this wall BG. Chuck you there. Okay, we come back to here. We're going to fill you in. F5. Yeah, it's good enough. Good enough. Because this is just a basic square. Well, basic rectangle rather. Pretty straightforward. What's that? Oh, no, I thought I saw an update popping up. Because it's just a basic rectangle, there are different ways you can do it. We could use a auto tile to draw out all the nifty individual bits and pieces, which I don't know, we might do later on. See how it goes. Yeah, that'll do for now, I suppose. Could put that in there. I'll keep it simple. We'll do slopes later on. Rightio. Basic tile map for testing. We need to do custom controls next. If that's the case, project input map, we're going to go move right. Wait. Move left. Move right. Move jump. Left, right, jump. Yeah, that'll do for now, I suppose. Okay. Define custom controls. Add gravity controls. We'll put that down there. Because if you say define custom controls there and be like, oh, what did I define for thing? Note for later. Okay, so that's the first part done. Here we're going to go kinematic body 2D. There we go. We'll call you player. We're going to add in a collision shape 2D, and we'll add in a sprite. A sprite. Thank you. 32 by 32, that'll work. We'll just make another fella down here. Actually, no, let's make him green. Actually, there, that'll be good. Actually, we'll go there and make a little, ooh, no, not that. Make a little face on him. And we go here. Sprite's going to put you there. Texture region is going to be grid snap, but we're changing your grid from 8 to 8. Whoop, 8. Yes. Zoom in just a wee bit. Oh, I can just do that. Alright, region on. So he's only going to be a small fellow. Capsule 2D. We're going to... Oh, come on. So he is 3 high. So, wait, no, not that. Come here. 3 high, that's 12. 8. Six. Wait. 12 radius is going to be 8. That'll do. Cool beans. Save you as player. Going to add in a script in a new folder. Create folder. We're going to call it scripts, and we're going to call this one player. Create. Boom. Create player. Platform controls. Use move and slide to start off with. I'm getting ahead of myself. Okay. So we go here. Define that. Going to go here. Going to go physics. Process delta. Whoops. Motion equals move and slide. Amped slide. And pop back into here. So we have, it returns a vector 2. Move and slide requires linear velocity as a vector 2. We're going to make a function that puts that in. Up direction is the normal in which the ground is facing. Think of a normal as being very similar to a direction, because it is. Wait, bit of a brain fart there. A normal is pretty much a direction represented as a vector 2. So in this case, this one's having 0, 0. and it's what we've used in all the top-down stuff. That pretty much says everything's a wall. But if you're doing a platformer, you need to say, okay, is the player or the object on the floor? In order to find that out, you need to be able to detect what the floor is. Which direction is it? That's the up direction. And, well, everything else is cut off. Stop on slope, maximum slide detection, infinite inertia, and there's like a few other bits and pieces, but we need to pay attention to these first two: linear and up direction. So we're going to call this get motion. That'll do. We'll go times by move speed, which isn't defined yet, but okay. Vector 2. Just use up for now. We just want to get the basic. You want to get the basics done. Just a basic player movement thing. Player movement script going. Move speed equals 64. You may say, oh, well, in the previous ones you defined motion, then chucked it into move and slide or whatever. Why are you doing it like this? We're going to be using something a bit more involved, because you need to detect jumping as well, which will be jump height equals 128 variable gravity equals I'll call you 72. Random values, but they're all in line. So that'll be the lowest, that'll be the middle, that'll be the highest. We need to get rid of this error here. So let's create a new function called get motion. Boop, 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 boop. We're going to go variable calc equals vector 2 0. Calc x equals int of input input dot is action pressed. Going to review, because we'll be we'll just have it chuck the motion there. We'll do all the calculations in here just to keep everything together and neat. Going to go move right. Take away the int of input action pressed. Left, yes. We're going to chuck all of you into here, and we're going to go times by move speed. That's a big chunk of stuff, but it's similar to what we do for a top-down movement using this branchless approach. So is right being pressed? Yes, no. 0, 1. Take away is left being pressed? Yes, no. 0, -1, all that kind of stuff. Get that variable times, get that result times by move speed. We're going to go if is on floor. If input.is action just pressed. Yeah. Move, jump. Calc.y plus equals gravity. So this little function here is built into kinematic bodies. Detects whether you're on the floor. So therefore, if the floor normal, like if the player object is falling and if it's touching a wall or something, it'll let you know, is it on the floor? Same with is on wall, is on ceiling, but for now we're focusing on floor. If it's on the floor, then you can trigger this over here. We'll be detecting if the jump button's pressed. If it's pressed, we're going to go, oop, come on, calc.y iterate, or increment rather, jump height. So this is left-right movement. If you're on the floor and you press the jump button, we're just gonna, this only triggers once, pretty much. Calc Y is decrementing, because if you add to the Y, then you're going down. We need to go up. If it's not being pressed, whatever, you still have your calc going. However, if he's not if the player's not on the floor, then we're going to increase gravity. Just to keep it safe, we'll go calc Y. Ran into this problem before with clamping. I think I got it working earlier on. If not, let's see. Clamp. Returns a float value. Clamps a value between, whoops, between minimum and maximum. A is 20 between there. Okay. A is 1 in between there. A is there. Okay, so equals clamp, and go calc.y. Minimum will go jump height. Maximum is gravity. Negative jump height. Yes. Wait, yeah. Hang on a second. Yeah. So return a value between minus 128 and 72. But we're going to chuck that outside of the else. We'll just make it in general. Then we go here. We return calc. I should do it. Full disclosure, it's been a while since I've done a platforming behavior. I've been focusing on top-down, but in theory this should work. If not, well, you can see me do my usual troubleshooting. Oh my god, I did everything wrong with the stream. How embarrassing. Okay. So, come in here. He's on the floor. Move left and right, and the space doesn't work. I just remembered what it was. Project settings, input map. It usually helps if you actually define the movement. Okay. Okay, so we're going to go left and right. Space this time. We'll just jump. We'll just do it as space for now. Everything works except it isn't. Being a bit of a silly bugger. Okay, left, right, space. Oh no, it's not working. What did I miss? Max gravity. Gravity equal gravity equals be a much smaller value. 16. Because if you think of it as in like, we just call it frames, like obviously there's delta time and all this other hoity-toity stuff. When the button is pressed, calc is currently 0. The next frame is going to be jump height. Down to here, it's going to increase gravity, so jump height will be 128 minus 72, which will only be a very small amount. Clamps the values, okay, that's working, boom. Comes around for the next frame. Not on the floor, so it's there. And it again, so right away that's like boom, straight to the floor. That's why it looks like it's twitching. Actually, we'll plumb this down even more. So if we make gravity as a really small number, so it adds this over time, just like so that eventually it'll move in minus 28, well, minus 128, but it will still have gravity affecting on it. So it'll be minus 128, take away 8, minus 120, minus 112, so on and so forth, over several frames. So we need to go here, go max gravity, jump height, max gravity. That's fine, that's fine. Memory serves, so that is really slow. We can move left and right though. Yeah. Still not working. What's going on? There. I'm just tweaking around with things. Okay. Go through the logic. Left and right, you're behaving as you should. Is on floor. There. If not, add gravity. Equals 0. No. We're going to set this minus jump height. Nope. If we crank up this, let's keep it 256. So that's still going there. What we're going to do is we're going to go print calc. How are we looking at for, see there, yep, that's behaving as it should. This is going to go nowhere. Yeah. I was thinking, well, we're going to take out this clamp for now. Gravity. False true. And that's triggering it off to the side. Okay. I'm missing something. Let's try you. It's going to pop an error saying, this is not returning a value. Yeah, I didn't think that would be working. Alright, let's try this. Motion equals get motion. Motion equals equals a negative jump height, of course. Well, once again, doing my embarrassing thing again. Well, at least I said I am a wee bit out of practice. That's probably the same thing. Good old 3 platformer behavior. What am I missing? Platform tutorial. Yeah, I'm sure that's fine. Kiss and code. Ah, these good guys. Oh, and there's 2D platform movement on slopes. 2016. Oh no. Ah, whatever. Supposed to use a rigid formula will make kinematic Speed, jump speed, gravity. Get input, velocity, velocity plus minus speed for walking left and right. Move and slide input, just press jump and fall equals jump speed. Friction, acceleration. Don't think we'll need this. Would be cool. It's getting the input. Okay. Velocity is gravity times by delta. Wait, you need delta values. Thought it was only with move and collide. Okay. Wow. Give it a shot. So that was, need to get the input. That's pretty much what I had before. Okay. So get, let's call this get input. Input, in out. Input. Calculus vectors, vector 2, 0, boo, 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 boo. Keep it simple like that. Calc times by move speed. Var calc equals vector 2 0. Zerp. 0. Please. Okay. So we put you in, you should move left and right. No, because we didn't put in move and slide yet. Apparently? Apparently. Okay, that's... Wait, how is that working and it wasn't working before? Like, I'm not going crazy, am I? So... 5... Wait, what? So... That was set up as it was before, but it was... I'm not going crazy, you guys saw that, right? Okay. It's working now. Don't question it, I suppose. Yeah, that's odd. Very odd. So congratulations, Hampo, you're finally losing your mind. Yay. Input, velocity.x. Question's going to be get input. Boop boo boop boo boop boo boo. Okay. Jumping. If is on floor. Calc y equals 0. Let's keep this base. Else calc y plus equals gravity. So no jumping yet. Just going to test this. because that's behaving. Okay. To double check, we're going to go print calc. Probably be an idea to print motion actually. So that has everything applied at the end. Okay. Okay. If input, oh god, I just realized what I did wrong before, is action just pressed, move, jump. I think I see where I went wrong. Calc dot y equals negative jump height, jump height. Yes, yes, yes. Dot y outside of everything, because that clamp shouldn't have been affecting too much. Calc y by the minimum will be negative jump height. The maximum will be, what do we call it, max gravity? Yeah. Max gravity. So he is jumping. We're going to bump you up to 256. Y. This might be where the problem is. Eight. Aha. What's going on here? Okay. Because I'm resetting it, I'm to keep redefining it. Yep, I see. It's my own fault. Tried to get too fancy. So I'm going to call you motion. Get rid of you. Motion. Motion. And I'm such a silly bugger. Print, and you are not returning anything. Whoa, okay. Moon jumping. Change that to press. Doesn't need to trigger once. When you're off the floor, it won't re-jump. It'll just jump, etc., etc. Jump height is going to be 128. Gravity is going to be 16. Max gravity is going to be 256. Should be fine. Move speed, jump height, gravity. Okay. So he is jumping. Oh, right about one high. Okay. So if we bump down the gravity and that's great. We might chunk it down to 192 actually. Might be a bit too strong. Okay, he's jumping a square high. Not as impressive as it's laid out here, but I think that could work. So congratulations, I showed you how not to make a programming behavior. Move speed. As for the gravity shifting, this all needs to be changed anyway, but we got the basics in there. Oh, that's embarrassing. My microphone's down. What's going on here? There we go. Oh, gosh, wonder how long that was like that. Anyways, more coffee. Force us to a single vector, rotate, change gravity. Oh, this is next. Oh, that's one thing I should add in. Unready variable sprite equals sprite. Let's go here. Just to add in something spiffy. You go sprite dot flip, which equals the boolean of. No. I'm thinking what's going on here. Let's grab that. We'll put it here. We go. Dot x. Less than 0. No, wait. Sprite. No, I'm getting ahead of myself. We'll go sprite flip h equals true. elif motion if dot x is greater than 0. Flip h equals false. So we should have a move dude moving left from right. Yeah. Just chuck that in. Why not? Okay. So I'm going to take a quick break, make some coffee. I'm going to tackle this gravity thing. Yeah. Yeah? Yeah. Okay, I'll be back in a moment. Okay. Adjust the chair. Alrightio. So we are doing alt tabbing apparently. Tie forces to a single vector. Rotate shift gravity with player control. Shift gravity, add gravity controls. I think we'll do it very basic at the moment. So the gravity will go cardinal directions. Once we get this part here, tying forces to a single vector. That'll be the tricky one. We get that sorted, then we can move to this one as a cascading list would denote. No, it's we get this sorted, so we can move left and right, but we're referencing one vector. So instead of just going update X along one axis like left to right as we have at the moment, it'll be apply the movement of left and right with X with actually hang on a second, yeah, X and Y in relation to the vector. So if we have a single vector, we can say gravity is going to be negative this vector or positive this vector. The vector also means this is what the direction the floor is facing. This is how all these other bits and pieces work. Then rotating, shifting, changing gravity with player control. Just added this one vector. Everything else should update. To put shift gravity just there, because we keep it simple. We're going to go rotate gravity over time. Okay, so first one is it's going to be similar to that VVV game I was talking about a couple of streams back. How you press a button, you don't jump, your guy moves left and right. Press a button, it flips gravity, and you can still move left and right, but standing on the roof. Then press it again, flips. Now you fall down to the floor, left and right. Except with this one, we want to do it on the walls as well, I think. Yeah, might as well. Yeah. The controls might get a little bit interesting. Well, we'll get to that later on. First, we need to get this vector sorted. So, create new variable. Root vector equals. We'll make this let's make it face up. That'll be the way to go. To up. Move and slide. We're going to go root vector. Now we'll change it up. Up vector. It'll just be a lot more straightforward because it's going to be the floor is facing up. Everything's going to be based facing up. For jumping, we're going to go up. We're going to go motion equals up vector times by jump height. Else motion is not going to equal 0. We don't need that because we fixed the error we had up here with it constantly saying it's 0. Motion is going to be plus equal up vector times by gravity. Flipping of the sprite. We'll leave you out for now. It's only just basic stuff. We're also going to leave out this clamp until we get things sorted. Let's give this a shot. Yep, we are doing this wrong. We need to go down, so that'll be negative up vector times by gravity. So that should go down, yep, and we still jump. That's good. Left and right. Be this one here. Let's see what we can work with using vector 2. Because the dogs have served us well in the past. I mean, that's how we got working out angles before. Angle 2, cross. It's cross. Cross product of this vector and width. Okay. We get something that returns a vector 2. That'll be excellent. Ooh, whoa, 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 whoa. No, thank you. Here we can interpolate. Direction 2. Distance 2. Floor of a vector. Length squared is normalized. Is equal. Approach, linear, interpolate, move towards. Normalize, posmod. Turns a vector, f posmod. The vector components, mod. Mod should be here. Okay. Floating point modules of AB that wraps equally in positive, negative. So we're going to loop for 7 times. X equals 0.5 times by 1 divided by 1.5. Print out that. So 0 would be 0 times by 0.5 is 0 minus 1.5. Boom, there. Yeah. Interesting, but no, don't think that's what I'm after. Project, reflect, rotated. Okay, let's look at these ones. Return. So the vector projected onto the vector B. Okay, reflected from a plane defined by the given normal. Ooh, that could come in handy for something else. Not quite what we're after though. Turns the vector in 5 radians. Degtrad. This sounds like it might be an option. It's working in radians, but we can go degrees to radians. We can go plus 90, minus 90, or what have you. Rotator, that's probably what we're going to give a shot. Sign. Returns each vector component as a set of 1 or negative 1. So you can see the sign. I opened up my eyes and I saw the sign. So we're going to chuck you there. We're going to go motion. Plus equals. Okay, so we'll set the motion first for left and right movement, because then we're applying the jumping based stuff. Okay. Get left and right first, then we apply up and down stuff later. As long as this works, then that can just be added on. That's working at the moment. So motion equals going to go up vector times by rotated, so clockwise would be 90, so I'll be deg to rad 90. Wait, that is returning a vector too. Better double check. Rotated. Yes, okay. So I won't get an error there. It's the up vector, rotate 9 degrees, which will go from this to this, hopefully. Times by int of put dot is action pressed. We're going to go move right there. There. Times by move speed. Got one button press in place. We're going to give that a shot. So, okay, it's going a bit slow. Alright. Yes. That's working. So that is an incredibly long version of what we had before, just corrected. Negative. Move left. No, no. Both going either way. Okay. minus 90. That's just going to be the negative of... Yeah, we can just leave that as is. We don't need to update this angle. There we go. Excellent. But our jumping is not working. Motion up vector, transfer jump height. Iterate. Instead of setting it once, just add on. No. Okay. Directly edit. We're direct. English. Directly editing motion. Maybe if we separate them. But then that's going to run into the problem we had before. No. We can fix this. We can fix this. Up vector times by jump height. Negative up vector by gravity. Max gravity. Let's try this. Oh boy, that's not working. Okay, yeah, that's a bit too much. Whoop, that's the wrong one. Okay. Oh. Yep, that's because that's supposed to be positive. So we're not using max gravity at the moment. So motion up, jump height, motion down. Going to grab this and we're going to put you into there, but we're not going to do it 90, we're going to do it 180. Yes, yeah, up vector rotated times by okay. left right equals vector 2.0 var up down equals vector 2.0. Bear with me for a second. We're going to go left right equals up vector plus the down vector times by move speed. That's sitting there as it should be. No, not up vector, we're going to go up, down. Up, down. Yes. Yes, yes. It's going up, that's going down. Okay. You guys need to go up here. So they need to be defined outside of there. That's fine. Then we go here. Motion equals up, down, plus left, right. Okay, so that's working for the moment. If we do clamp here, we go up, down equals the clamp of... Can clamp be used that way? Can I clamp a vector? Logic clamp, visual shader, vector 2 clamped. Aha! Length float. A maximum length by limiting its length to length. So let's try this. Clamp, we're going to go up, down, X. Affect the jump height. Up vector rotated. Probably not going to work, but up down dot x, up vector dot x, jump height, up vector dot x, no wait, not there, we go here, rotated dot x. That's my max gravity. X. Vector 2 float. But that is a float. Okay, overthinking it. Up, down, dot x equals, we're going to break it up again. Clamp, up, down, whoop, dot x. Yes. 0, 1. Is that working? Yes. Okay, so we're going to replace the 0 for the minimum value, which is going to be up vector dot x times by jump height. So it's going to be up vector rotated deg to rad 180. Yep, and we're going to go dot x times by gravity. I hope this works. That's all I've got to say. So this is just manually putting in the clamp value that we have down here. This clamp only works with float values or single ones, so that's just for y, just for y. Those are fine. This we have to do it for x and y. Then we add them together and put it there. That needs to be max gravity. Before we forget. Okay. Okay. Equals F5. Okay, and all of that is tied to a single vector. Ooh. Okay. Oh, you look at the values down here, they're kind of jittering around. Let's try that. Get rid of that jittering thing. So you are close enough on the floor. Okay. That's sorted. Cool. Shift change gravity player with player control. Of course. So we can get rid of all of this stuff. Whoop, whoop, there. Jumping. Clamp. Vertical. Clamp vertical direction. Combine. Into motion. Vector. Okay. That is... It's working. Bit technical, but I think I get what's going on. Two vectors, left and right movement, up and down movement relative to the player. Combine the left and right and up and down together into motion. But to make the jumping behave correctly, you need to go into the up-down vector and clamp it so that it doesn't go outside of said parameters, because it stops you from falling down at infinite speed. It stops at a maximum falling speed, which will be max gravity. Gravity. So yeah, we're using all of that. That's okay. Okay. Put you there, and we're going to define you in the very beginning equals vector 2 dot up, up, up. I reckon we chuck up the jump just a wee bit. Go 192. Yeah, let's try you out. Ooh, that's a bit much. So I'm just thinking... Actually, no, that'll be just enough. Because if we jump back to level and we chuck down a... I should make another tile. Sprite. Canvas size. We'll make you... Wow, 128. Chuck you there. Are you keeping up with the Commodore? Because the Commodore is keeping up with you. Up there. So just realized that we need to have something to jump onto, and we'll keep this like that. Itchy. Okay, here, then we go here, and we go new single tile. We're going to go here. We're going to call this a box. Collision's going to be square, we're going to drag it like that. Okay, no, that's good, that's good. Okay, so... Player. What's up, player? Gravity update. Project settings. We're going to add in some more inputs. Gravity left. Gravity right. Yep, and so we define those because we're going to make it shift left and right. Okay. Well, not so much shift, rotate. It will make sense in a bit. That's fine. How should we do this? Gravder equals, not a dictionary, we just need an array, I think. So we define all of the different positions to up to down. No, we're going to go right. Keep it clockwise from top, so up, right, down, left. To dot left. No, we only need, yeah. I'm just thinking, what if there's no gravity? Different feature, different time. We'll just keep it to shifting gravity for now. So, up, right, down, left. So we do. Okay. Go here and we'll do up, right, down, left. Let's keep you in like that. So varchar equals 0. Going to change you to grav dir grav dir. You should still work, hopefully. Left, right, jump. Okay, that is good. Good, good, good. Whoop, let's go there. Sprite. Flip. God, it seems like I'm just wasting time. Like, oh, adding this and this and this. Sprite dot. Where we go? If put dot is action equals true. If input dot is action just pressed, move right. Whoops. Come on. That is already going to pop up an error because that's a comma, not a full stop. We go sprite flip h equals false. Boop, 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 boop. Okay. Okay. Save. Will I have time for Razzle Dazzle at the end? Let's see. Oh, the stream today started a bit late. Yeah, just... Well, there's no way around it. I accidentally slept in. Like, just laying in bed going, yep, look at the time. It's like, oh crap, I got all this stuff to do. So I got up, had to do all these errands earlier on. Then it's like, okay, stream. Let's go. I don't know. At least I'm doing something. So we're going to grey. Yep. Input dot is action just pressed. We're going to go gravity left. Pass. Input dot is action just pressed. Cause gravity right. Okay. Equals. I think it was called wrap. I remember seeing a while back there was a built-in function. Oh, actually probably help if I look it up. I think it was called wrap I or wrap F. Wrap I. Oh yes, wrap F. Okay, they both exist. Returns an integer of a value. Oh, no. I'm in the middle of reading. Minimum value, maximum value, and it wraps integer value between those two. So creating loop-like behavior or infinite services. Note, if min is 0, this is the equivalent to posmod. That's popping up again. So, if that's the case, I'm going to keep this more simple. We're going to put in a vector 2.0. When we do, we're going to make it up is 1. So we go here, we go wrap I. Dir. So that's going to the left, so that'll be there. -1. Minimum value will be 1. Maximum value will be grav dir length. Array. Hang on a second. Is it length or size? Methods. Size. Turns the number of okay, it is size. Okay. And wait, that is, yeah, it's okay. Size. Okay. Here, and we go here. We're going to make that +1. Dir is taking dir and is adding 1 to it, and it is wrapping between 1 and maximum. This will be 1. Oh, 1 and 5. Hang on a second. 1, 2, 3, 4, 5. Yes. So that'll be size -1. Oh yeah, that could have really messed us up if we weren't careful. That's because we're not doing this. So we go up vector. We got it there. Grab dir plus dir. Okay. That's not working. It's changing some. Whoa, okay. Whoa. I'll just do. Whoa. And we're backwards. Okay. So, I was afraid of this. Okay. Need a way to check to see how this is working. Scripts level 00. Going to go unready var player equals player. We're going to make a new object. We're going to call it a line 2D. Yes. Said line 2D, we're going to make you greenish, I suppose. Transform is going to be 64 by 64. So you're going to be sitting there for now. Z index is going to be 10. It's going to be above everything else. We are going to go points pull vector array. We're going to have 2 points. 0, 0, 0, 0, 0, 1. Save. Whoa, no. What are you doing? Okay. Line 2. Whoop, that's the wrong one. Okay. Line 2D. Line points. Not sure about this one. Line 2D. Endpoint, repoint, get point count, get point position, set point position. Set point position. One with player dot vector times by vector to 32. Test this. Yes. Okay. I'm gonna put you there. So if I rotate to the right, yes. One, two, three, 1, 2, 3. We are missing out on something. I think it might be. Let's try this one. Okay. It has to do with manipulating the vector. Go there. We're going to go with curve, new curve. Add point. Load preset. Ease out? No. Ease in. direction. Okay. So left is moving right. Wait. So that's moving left. That's moving right. Okay, so the left and right are behaving as they should. So is the jumping. That's working fine. That's working fine. That's not. That is. So what am I missing? So close, so close. Negative, okay. Funny thing is, similar to the problem I was having before. Except it wasn't the jumping, it was the left and right that wasn't working correctly. So as in, you could jump correctly in all different directions. It's just... I'm going to think on this for a bit. I'm sure we can work something out. Unless there's another way of doing rotated. Though that is working really well, like the left and right are working just fine. Well, let's find out in a bit. I'll be back in a moment. Get some more coffee, and yeah, see what we can do. Rightio. Let's look through all this, see what we can sort out. Work the problem, so to speak. Left and right is working. We know that for certain. Jumping and this isn't working. So, don't think we need to rotate here. So we're going to get rid of you. Negative. How would that work? Should still work. So there's jumping there, that's fine. And the arrow's pointing up, that's the up direction. We shift. There. So this direction. Okay, if we click back to here, that works as normal. That doesn't work. That works. Left, right. Left, right. Left, well that's not working. Right. Okay. Left should be against there, right should be going that way. Alright. Left, right. So, sorry, that just having a bit of a cookie. So might be the clamping. Oh, whoops. Put you out for the moment. Left, right, jump. Boom. Left, right, jump. Aha, ha, ha, ha. There we go. So that's what was messing it up, the clamp. So we're going to have to find a way to clamp that. Well, not really. Is terminal velocity, like, you know, maximum falling, is that really essential? On face value, no it isn't. You don't really need it. I reckon give this clamping another shot. At least for a little bit. Actually, no, it should be straightforward, actually. Hang on. We saw something earlier today that might help us. Because these are working as vectors. Well, grabbing components of vectors. And we saw hang on a second. So replace this with just your regular negative. No, that'll be something if what I'm thinking of doesn't work, probably tweaking this. But we had in vector 2, I think it was called absolute values, abs. Turns a new vector with all components in absolute values, i.e. positive. See if we can get maximum. Hang on a second. It's getting a bit of a brain teaser. This is actually quite interesting. So return the absolute values of everything, like even though up would be, say, negative y, like along the up direction. Return that as an absolute, then make it negative. So when that shifts to the side, there, because that'll be positive if that's flipped around. So, What have we got? So there was another one here called clamped. What will that do? It's length to length. So we've got length here, don't we? Magnitude of this vector. Okay, instead of clamping, we could use this length thing. We'll make it max 4. Wait. This jump height and max gravity are the same values. That seems to behave correctly. So we don't really need max gravity because we can just say maximum jump height. Or max jump height. Well, the jump height as max gravity, rather. So we're going to chuck you out of here. So we're going to go up, down, or no, not up, underscore down, up, down, equals up, down, clamped, up, doppelman, clamped. Length is going to be jump height. I should fix it. So jump there. Yeah. Well, that fixed that. Clap. Works surprisingly well. Excellent. Okay. Shift gravity of player control. Rotate gravity over time. Over time, you say? What? So we're going to do that. Shift gravity with player control. Rotate gravity over time. Now, more of the razzle dazzle, so to speak. Let's razzle dazzle. We're going to chuck in rotate gravity over time. Rotate player to match. Rotate player to match gravity direction. Okay. Probably sort out those ones. Well, aside from adding in a side-scrolling platform animation, I don't think I have one prepared. Rotate over time. Well, if it's interpolating properties over time, then I'll be using a tween. Yeah. So, okay, gravity update. So we are going to get rid of you. Going to do some references. Okay, former variables. Gravity variables. Grab you. Going to put you there as reference. Platform of variables, gravity variables. Call this one gravity shift. Shift. Alright, so we're going to go and add a tween here. Say node I haven't used on stream before, but the gist of it is it doesn't exist as a physical object that you can click on. Like, it isn't like a collision shape 2D or a sprite or a label, a color rect, a what have you. It just sits there. And it gives you these options over here, which, to be honest, I don't really use. I just reference it via code. What it does is it takes one property. It takes one property that's referenced, has a start point and an end point, and after that it has a value for how long it's going to take, usually in seconds. In fact, it is in seconds. Oh dear. So it's in seconds, and it, when you call the function on it, which says it's like start method, I think it is. Let's go start, and it performs the action over time, going from value 1 to value 2. Normally it's like, okay, that's interesting. What really does that have to do with anything? What it has to do is that it can be almost any value. It could be a float, could be an integer, could be a color, could be a position, which in this case, position is a vector 2. Because the up direction is a vector 2, that's what we'll be manipulating. It takes care of all that stuff in it. However, we want to shift gravity from... I'll just build it first, see what it is. So we got between there, gravity shift var change equals false. Putting that there for now. Gravity How can I plan this out? Because it's going to get a bit tricky. What you do is press button. Makes change to true. If true is running, then you can't accept any more button presses. Signal would be the best way to go. Yep, okay. Change. On ready, we're going to go connect, change to self. Call this gravity change. Sure. Arguments. It's going to pop up with an error because they're not defined. Yep. We'll just keep it simple. Change, self, gravity change. Cool. Okie dokie. We are going to go to here. Chuck you down here. We're going to call you func gravity change. You're going to require a new yes, okay. So we're going to we're going to set change equals true. Between interpolate property. object is going to be self. Property is going to be up vector. Up vector so we're going to change up vector, starting point up vector, then we go vector vector 2 dot zero. To go from up vector to new up over 1 second. Don't really need tweening at the moment. Tween start yield tween completed. Next is going to be change equals false. If not change, we're going to call emit signal change argument. We're going to call it don't need new up. Going to call grav dir grav.dir. Not sure if this is going to work. Let's throw out some things. There we go. Base tween cannot convert vector 2 to node path. Okay. So I'm missing something. Interpolate property. Property of object. To node path. Property vector 2 to node path property. So I'm missing something. Interpolate property. Or is there something else we can do instead? Follow method, follow property, get runtime, interpolate is active. Start targeting method, object method. So on, gravity, resource 5, move speed, jump height. Move speed, jump height. -1, up vector. Again, this isn't necessary just to make it look spiffy, but if we get this to work, just adds a little bit of extra polish. Node path, pre-passed scene tree. Relative to the current node. Right, get tree there. Expected 5 arguments self. Is that a string that's required? It is. Ooh. Okay, that's kind of cool. Okay. Vector. Can we make this normalize? No, let's change it from 1 to 1. So we're going to go here and we're going to go no, it's still not working. Not really that big of an issue. Is it? It's new. I suppose the next thing to test is I'm going to mesh down on this. So that's not changing there. That's good. So the signal system I got set up, that's working. So you don't want to do, okay, we're going to start a tween. While this is yielding and waiting for the tween to complete, I suppose you can do all completed, but you're queuing up even more stuff when you just want to change it from one to another for the moment. Okay. it's just working stuff out mentally. Rotate player to match character direct to match gravity direction. Get input. We're going to go rotation agrees equals up vector angle 2 vector rotated minus 90, maybe. Vector angle 2. Let's give it a shot. Let's try this. That's probably in radians, I think. Angle 2 is a floating point in radians. There you go. Rad to deg. Whoops. Rotation degrees from 0 through to up vector from 0 to there. Let's do just the sprite for now. Okay. So I'm not going to print motion, we're going to print right rotation degrees. How is this working? It's currently 0. That is also 0. So much 0. god, rotation degrees, background sky, background sky. Oh, it's 3D, okay. We'll go set rotation degrees, okay. Where are we? There, here we go. Set rotation degrees, boom, 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 boom. In degrees float. Okay. Then let's try this. Transform. Reset rotation degrees. Yes. Okay. Okay. So I'm probably missing something there. Going to create angle. Of course it's going to pop an error. It's returning a float, so we're going to get up vector angle. No arguments. Okay. So rotated. Well, that has to be degged to rad as well, isn't it? Oh, got rid of it. Okay, vector 2 rotated. Getting there. Slurp. In radians, that's okay. Rotated. Rad to deg, we're going to add on 90. It's an extra angle. We've got the angle of that. Oh wait, no, it needs to be deg to rad. Deg to rad. There. The angle of that's going to be returned in radians. So we're going to get radians to degrees because rotation degrees is in there. Maybe. Please. Yeah, that's pretty cool. I will tweak the rate at which it changes. Let's go 0.5. See how this behaves. Yeah. Whoa. So I'd add in a little bit more interesting stuff to it. Let's grab this. Let's put in a few boxes like this. Let's go here, add in a new tile, go here, here, a single tile, shingle, we'll just call this void. We're going to make this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's make it 10 by 10. Maybe. Whatever. We'll just fill that out there. Ooh, whoops. Let's make this what happens if we really speed up the thing? Let's go to 5. I think I see why that's getting that little twitchy thing, is because we're updating it here. We put that just before. Yep, that's the ticket. Cool beans. Controls are a little bit jank. However, we're going to go project visible, not navigation, collision. That's because I'm only doing the sprite. Okay, now that's fine. We go not here to sprite, we go to self. Now that should, because we got rotation degrees on kinematic body, it's a node TD, which we had, somewhere here, there. Because of inheritance, kinematic body should inherit node 2D. Which we'll just check. Kinematic body 2D inherits node 2D, so that rotation will be fine. Because when I tried to rotate color rect or label or stuff like that, those are control nodes, not node 2D or node 3D. So yeah. Whoa. Okay, so you can fly around a little bit. Whoa. Could be another game in itself. Like, I don't know, you have to make a spaceship or something. And you have to control it. It doesn't have any brakes or anything, so you have to control it non-stop through a course. If you hit something, then you explode. I don't know. Yeah, it could be an option. That's the thing, like, no real plans for using this or anything, it's just experimenting. Fun. Okay, that works out just fine, I suppose. Yeah, I'd say that's successful. We got there in the end. I mean, I don't know, I think it's a good thing that I show the areas that I mess up. Just not just like a humbling thing like, oh, I'm not perfect or anything. It's just it's a lot of what experimenting like this is. It's a lot of trial and error, but failing successfully, that's the important thing. Because if all you do is show your successes, then it'll be like, oh, that must be easy. It's like, oh no, boy howdy, it's not easy. All this is just off the cuff, on the fly, improvised. And yeah, it's good. Shows, you know, thought process, how to work through things. It's a pretty good chance if I keep doing these experiments, there'll be a day that I fail. Like, it's like, yeah, this is just way out of my league. And I'll fully cop to that. I mean, as long as I give it a shot, that's the important thing. Okay. I suppose we can mark this off. So yeah, I'm actually rather enjoying these kind of streams. Just experimenting with different things, different mechanics on the stream. I'm finding it actually kind of fun. I don't know, what do you guys think? Do you like this kind of content? I mean, I can go back to doing just, you know, basic do bits for Gold Bounty or other games, but yeah. Bit more interesting. Well, I think this is a bit more interesting. And yeah, I don't know. I'm just thinking out loud at the moment. Holy dooly. Rightio, so see, all that's done. So yeah, I'm going to call it here for now. Once again, thanks for watching. Hope you liked it. Links to my itch.io and Discord, they're in the description if you want to check them out. Yeah, thanks for watching. See you later.